I think it's recording. So today I'm gonna make my new website. I wanna learn about WebAssembly and Rust. So I will use the opportunity to learn about WebAssembly and Rust and also make my new website. So let's go. I don't know anything about Rust or WebAssembly. I know the WebAssembly is very similar to Lisp. It uses as expressions, but I don't know any more than this. And I know very little about Rust too. I made just a Hello World program in Rust, but more than that, I really don't know anything. So I'm gonna search for a WebAssembly Rust course, something like this, that I can follow and make my website. So I'm gonna write down some objectives that I want to accomplish in this video. I created here some compile Rust and assembly and print a pixel on the screen, like the basic stuff, the most basic stuff that I can think about it. Let's see here. Yeah, I think it can be more basic than that. Then after printing a pixel in the screen, I wanna draw some text in the screen, like draw text in the screen. I don't even know if this is totally possible because I know that you have to use JavaScript anyway, even if you are using Rust in WebAssembly. So I don't know if I can use a canvas only with Rust, because the idea of the website is to be done entirely in the canvas, not using HTML, just drawing things and drawing text and animating things, things like that. So I really want to do this only with Rust, but I don't know if it is possible without using JavaScript. So, but anyway, let's go. So this is my primarily objectives for today. Like first print a pixel on the screen, then first compile Rust in WebAssembly. Like I wanna understand how these things work. How can I iterate in the development? How can I create a nice development environment to create Rust WebAssembly apps, and understand also the advantage of using something like this. I know that one of the biggest advantages is the fact that Rust is pretty fast and that you are using a compiled language in the browser, so it should run pretty fast, a lot faster than JavaScript, and that's why I'm thinking of using Rust in WebAssembly to do animations, because I think animations in Rust WebAssembly will be a lot smoother than using JavaScript. So I'm gonna compile Rust in WebAssembly, I'm gonna print a pixel on the screen, I'm gonna draw text in the screen, like it's my personal website, so it will be something like, hello, my name is Marcel and this is my website, something like this. And then I really wanna, I like to publish anything. I don't like to wait a lot for putting things out. So my next objective after writing some text in the screen will be just to put the site on the air. Put the site on the air. Very simple. And then after putting the site on the air, I'm gonna start the animations. Like try not, and like I'm gonna do the animation. Do the animations. Cool. So that's pretty much it. So I think I created a folder here where I can work on. Right. So I have a folder here already. Let me just see if I can remember how to increase the font size. How can I increase the font size? I forgot. I forgot how to increase the font size, but I think the font size is fine. Okay, Uh, Russian WebAssembly. I think I already read this, like the setup. Yeah, it's pretty straightforward. You just need to install Rust, install Cargo. There's not much to talk about here, really. My webcam is in front of the the arrows for next, so I'm gonna click here. Hello world. I think I already done this. Oh wow, there's a yeah. That's some of the things that I don't like about Rust is the fact that you have a boilerplate creator. At least in this tutorial, you have a boilerplate created, and I don't like this kind of stuff. But I'm gonna follow the boilerplate creation because I don't understand Rust yet, so I cannot do it for myself. I know that you had to install this thing, cargo generate. I'm gonna put a terminal here just so I can check for things. Like, I don't know if I have cargo generate installed. Yes, I have. So I can create, so I'm gonna do this. I'm gonna go to my personal site. Yeah, I'm gonna have to change the name of this folder because this folder will be just testing Rust, something like this. It's not gonna be actually my website because my website I have to recreate it with this boilerplate thing. So I'm gonna rename it to testing Rust. Cool. Now I need to use this cargo generate thing. So I already have npm. This is still npm, right? npm is back. Yes, I already have this. Cool. So this is the setup. This is the hello world. Now this is the project template. Now I'm not sure if I should use this for my website already, because in this tutorial you learn how to create a game in Rust, and it's not a game that I want to do. The thing that I want to do is, I think it's easier. Like, it's harder in the sense that the animation is going to be hard and something like this, but I just want to understand how Rust works. I don't want to make the entire game. I just want to make my website. Anyway, I'm gonna follow the tutorial anyway, just to see what I need to configure to use Rust. Pretty much start development environment in Rust and WebAssembly. This is the thing that I don't know how to do it. Like, after I have the development environments and everything set up, I'm just gonna program basically. So the programming, I know how to do it. And so let's generate this thing, project name. I think I'm gonna use personal site because it's gonna be my personal site. Even if I start as a game or something like this, eventually I'm gonna turn into my personal site. So I'm gonna just write as personal site. Okay, so the project was created. I'm gonna I'm gonna go to a different terminal so I can better see what was created. Cool. What we have here? We have a bunch of folders. We have the source, the lib, rs, utils, rs, tests. Cool. I don't know what the fuck this is. App veil. App veil, I don't know. Is not defined address flags, build false, cargo test. I don't know what the app veil is. It looks like like scripts to run, like run tests. It's just a bunch of scripts, I think. What else do we have here? We have cargo. I know that this cargo 2ML is like the package JSON of Rust. You have the dependencies here, but the format is it's pretty much this, like the name, the version, the author. It's the package JSON of Rust. licensing doesn't matter. The README, it's also pretty straightforward. It's the same thing as any other programming environment. I think I'm done here. So let's keep following the tutorial. New project, cool. What's inside? I already saw what's inside. libhash file is the root of the Rust crate that we are compiling to WebAssembly. Using binding to interface. So there's already a lot of code here in this librs. But what do you have here? We have stand crate, module tunes. This is the hello world. How can I build the project? We use Wasm pack to orchestrate the following build steps. Ensure that we have Rust on newer and no targets installed via Rust up. What? And the Wasm turned to unknown targets installed via Rust up. How can I ensure that? I don't know. I know how to see if I have Rust up, right? I can see the Rust up version. Yes. It's 121? No, my Rust version. Don't I have just Rust? Ensure that we have Rust. Oh, I don't have Rust that new, right? Rust up. Oh, I have a very old version of Rust. How can I upgrade it? Let's see if I figure out how to upgrade to Rust. Show update. Yes, there's an update here. Show Rust update. Oh, I hope it doesn't take too long to update Rust. When I tried to install Rust, this cargo boilerplate thing, it took so long to install it. I hope just upgrading the language, it doesn't take that long. Installing component, yes. Rust up version. Well, I'm still 121. Show default, set the default to chain, check for updates to Rust chain. I think I need the latest version, right? Rust up. I have a check command. Stable, up to date, 144.1. But then when I do Rust, I think this is the version of Rust up and not the version of Rust itself, right? So this is the version of Rust up, 121. And my Rust version is 141. I think that's it. But let's just keep going. We mentioned the router interface, compilers into assembly, binary via cargo. Use Wasm binding to generate the JavaScript API for using our Rust generated WebAssembly. To do all of that, run this command inside the project directory. Wasm -pack build. So Wasm -pack build. I hope it works. Wow, it takes a lot of time. Man, it's fucking slow. Like this is compiling hello world and it's taking that long. Really? When the build is completed, we can find its artifacts in the package directory, and it should have these contents. Package JSON, README, Wasm, Game of Life, BG, Wasm, TS. Oh, I see. So after compiling, we have the JavaScript part and the WebAssembly part. The WebAssembly part, like the browser can execute, and the JavaScript part, of course, is the I think it's the bindings to the DOM, because I think you can actually use like directly. You can write like WebAssembly that changes the DOM. I don't think you can do this. Cool. They're explaining here each file, what each file is. File is the webassembly line that is generated by Dash compile from our source, contains the compiler and value. The DOS file is generated by WASM binding and contains JavaScript glue for importing down JavaScript functions into Rust. Yes, that is what we're talking about. You can actually manipulate the DOM directly in WASM, in WebAssembly, in Rust. You actually have to use an API, JavaScript API, to manipulate the DOM and change the things and things like this. API to the WebAssembly function JavaScript. For example, there is a JavaScript reach function that wraps the reach function exported from the WebAssembly model. Right now this glue isn't doing much, but when we start passing more interesting values back and forth between WASM and JavaScript, we help shepherd those values across the boundary. Cool. So we have cool. You can import WebAssembly into JavaScript and run a function. Boy, that's really nice. WASM TS file contains TypeScript type declarations from the JavaScript glue. If you're using TypeScript, you can call the WASM function time check. And UID can provide automatic completion. Well, the package is pretty much what I expected. What I would expect. Like, yeah, it's just the same thing. This package file contains metadata about generator. Putting it into a web page. That's a good part. Putting it into a web page. To take a WASM of Game of Life package using a web page, we use the Create WASM App JavaScript project template. What? Do I need to use another template? And payment template for consuming host WASM packages. What? So now, let me see if I understood this. We use one boilerplate to create the package. Now I have to use another boilerplate to consume the package and use it in a web page. Oh, this is really, I think it's unnecessarily complicated. But we'll know more about it after I done the things the way that this tutorial wants me to do it. Like after I do this, I'm gonna try to simplify the development environment a bit. So after like 5 minutes, the compilation failed. Probably FN set panic hook. When I finish release installing the combined function is never used. There is a function that is never used. Oh, this is just a warning. It actually compiles, and it doesn't take long to compile again. Yes, it's pretty fast to compile again. Cool. So let's install this other boilerplate here. We use the Create WASM App JavaScript project. So I have to run this command within WASM Game of Life directory init WASM app. I don't understand this comment, like what I'm doing here. What is WASM app? I understand that this comment is used to create pretty much the hook between the package that I just built and the web page, but I don't understand exactly what this comment is doing. Anyway, I'm gonna just copy it to here. Did I not copy it? Copy it, please. Gonna run. Here's our new WASM Game of Life. He creates a www directory inside the app. I think this directory is actually this directory gonna make the bindings between, not making the bindings, but will make it possible to use the package that I created with the in a website. Once again, let's take a closer look at so I have two different package JSONs inside one project. I have one package JSON for the cargo thing, for the package that I created, that is actually the meat of the app, and I have another package JSON for the website part, for the website integration. It's a webpack build. Have an index. The index, how the index imports I don't think the index imports anything, right? He's not importing the index.json. I see. So the index.json imports the hello WASM pack. Cool. Install dependencies. Further show that the local development server its dependency install. Now I have to install the dependencies for this project. I think I need to go to the directory, right? I need to go to the website directory and install the dependencies. Installing the dependencies, I'm gonna install webpack, it's gonna install all the things that are being used here. And the command only needs to be run once, and we will install the webpack directory button, etc. The webpacks are required for working with hosting WebAssembly. It's just a blunt development server. We're choosing for convenience here. Parser and rollup should also support importing WebAssembly as ECMAScript mod. So we don't actually need to use webpack like for nothing. No, actually, I think we need, right? We can write I don't know. I have to read the code to try to understand. So it's all everything. Back without hosting everything laptop on the. There's a link to use it without a bundler. I find this a lot more interesting because I can actually understand what's going on. This number shows how the target web flag can be used to load the code in the browser directly. For this deployment strategy, bundles like Webpack are not required. For more information, deployment, see the dedicated documentation. Very cool. I'm gonna save this thing because I wanna read it later. So I'm gonna save it here. I'm gonna create a read later. Cool, but now I'm gonna keep following the tutorial because my objective is not to build without Webpack. My objective is to build anything using a local WASM file packaging. Rather than use the hello. Now I'm understanding the shit. Can I really run the hello world here? Where is the package JSON? Do I have a start? Yes, so I have a start, so I can npm start. Cool. It started, or did it fail? No, it did not fail, and now I can go to local 8080. So this hello world is being run through WebAssembly, not JavaScript. Very cool. So let's see what is happening here. Let's just enter my site again. Cool. This is the index. I think this is the thing that is running. Yes, it is the thing that is running. And this thing is importing hello WASM pack. Where is hello WASM pack? Oh, it's not here anywhere. Oh, creating WASM map. What the fuck is this? Spawn required charge folder process. This is the script that created this folder for me. Node modules. So the hello WASM pack is really cool. It is a Node package that actually it is It is a Rust package. The Node package that is actually running WASM. Really cool. So I can easily create Node packages that uses WebAssembly that like just import. Wow. Now I see why people like WebAssembly. You can just create a Node package written in WebAssembly, import it into your project and run it just like that. Really cool. So, but I guess I can also run locally because I would like to understand how to run locally instead of using a different module. For what I understand, reading the tutorial here, you can't do this, right? The tutorial didn't give me any option to run the .wasm file locally, like import the module locally and just run it. He first teach me how to create the WASM module, then how to import it in a different project. Yes, so I think I need to have this. I need to have package JSON, a different package JSON for the module to import it. I guess. I'm not sure actually. I would like to test these things out just to understand how it works. Yes, I really would like to do this. So I have an index here. Yeah, but to do this I have to follow the building without webpack thingy. Yeah, and I don't want to read this right now because I want to complete my objectives. So I'm gonna keep doing the tutorial. Afterwards, I think I'm gonna read how to do this like manually and better understand what's going on. Like I know what's going on. I know that's the how it's working, how it's important in the module, but I don't know what can be done. I don't know if you can create a WASM file and just import it in JavaScript and execute it, right? This is the thing that I don't know, and I really wish I know it. So packaging rather than use WASM. Right now we want to use a local WASM. So I need to. He's using a Hello World package, but now I need to import my actual code, my WASM Game of Life package. Open up JSON and add dependencies to include WASM. I see. This is really weird. Why doesn't he import it directly? I think you can't. That's the thing that I'm really pissing me off. Like why he's not importing the project directly. I have to put the thing here. Now he's importing a file that is outside this folder. So he's importing this folder, and this folder have this pkg. I think this pkg is the important part, right? Yes, it's the build. Now I understand. He's importing this guy. There is the build. I think there is a main here, right? Well, no. There is no main. There is no main, but there is a file array. So he knows the things that he has to import to use this thing. And it's not just WASM. You cannot create just WASM and import it, I think. So we have to create this JS file. Actually, this JS file yes, this JS file is doing the binding between yeah. I'm not sure, but I'm gonna test some things out later. And for now I understand what he's trying to do, so let's keep going. Yes. Yes, installed everything there. Cool. You have the package here. Install the shit there. Next, modify WebAssembly, remove line from text to import WebAssembly. Yes, this is pretty obvious. Now I have to change the import here, right? I have to change to the name of the other package that I don't remember. WebAssembly Game of Life. Cool. Now it should work. WebAssembly Game of Life. So when I close this, when I run this again, start. I'm typing very badly today. I was working on my MacBook, so I can't resolve WebAssembly Game of Life. So there's probably something wrong with the import, right? This WebAssembly Game of Life file. Well, I just followed with the things that he told me to do. So one directory above package looks fine. I cannot resolve WebAssembly Game of Life. I think WebAssembly Game of Life. Did I write it wrong? WebAssembly Game of. Oh, no, I think it's right. Let's check it again. WebAssembly Game of Life. Right, this is right. Let's open the package.json. Yeah, this is right. Why you no work? Can resolve WebAssembly Game of Life. Do I need to install it again? I don't think so. Like I just need to make the reference to the other file. Oh, this is dependencies instead of dev dependencies. So let's add this line. But what is the difference? Why I can not put this in dev dependencies? Like the other one worked. Like there's no reason for this one not to work in dev dependencies. But let's just follow exactly what the tutorial is telling me to do. So now it's right, dependencies, yes, and the import is also right, yes. So please work now. Now it worked. I don't know that you couldn't do this in dev dependencies. Anyway, let's keep going. So now I imported. Now I think I can run this thing. Yes, hello personal site. Really cool. Cool. So now I can like change something here, right? I just want to change something to see it working. So I have hello personal site here, and I can write. No, actually I can write anything, but I can like do some. Oh, and it is actually calling the function here. Oh, this is the binding. WebAssembly binding. So you have to declare the bindings that you want to use here. So he's declaring this alert binding. So Rust understands that this alert is actually the browser alert. Now I can call this thing. Now I see how this is going. I think this is gonna like declare other bindings here, like DOM bindings, just to change things in the screen, things like this. Yes, and then you can use the thing here. So maybe you can actually just write Rust without writing too much JavaScript. Let's see. Let's keep following the tutorial. And he's running the grid here. How did he import it? He imported the grid. I don't remember. Yes. Oh, I see, I see. He imported everything as WASM, and then he ran the the function reach. The function reach is here, right? Pub function reach. Man, this using tabs instead of spaces, savages. Important independence and declared independence mutual. Oh, you need to also run independence though. What? So weird. A web page now ready to be served locally. Cool. Now this everything is right. Modify the greet function to take a name string parameter that customize the alert message and pass your name to the greet function from inside. The build WASM binary with WASM build. Man, I have to run WASM build every time I build the thing. Every time I change anything inside the website or inside the actual Rust package, I have to run the build again. Yeah, I don't think it's a big deal actually, because I can create a script that does this for me. A function from inside WASM, I have built the WASM binary with WASM build. Then refresh locally. I have to manually refresh. Why is not using Webpack? I don't have to manually refresh. Oh, I have to manually refresh because I'm building the Rust package, and the website doesn't know that the Rust package changed. So I need to build the Rust package again, then refresh the browser to see my changes. Cool. What else do I have? Rules of common game. I don't care about this. Fuck this shit. This is the actual game. Implementing commons design, financial. This is just not related to what I want to learn. I want to learn how to, like, my objective is to print something on the screen, right? How does he print something on the screen? Here's just code to you have a display here. What is this right thing? WASM bind jam. Wait. You have this WASM bind jam and WASM. No, both of them is WASM bind jam. How can I write anything in the screen? This is what I want to know. Can I run this? No, I actually can. Universe, cool. Handling with JavaScript. This is the part that I want to know. First, select the elements WASM given of life to render the universe into just above the script tag. So I need to change the HTML of the web page. Let's do this. And I should change the HTML, and I'm gonna do this right here. Let's just enter the search. Actually, just enter the thing. Then I have a HTML here. Please open. Can I close this shit? I think I can. But anyway, let me just have some more space. More space, man. Give me more space. Cool. Now I need to put this shit here. And first add the pre-element to WASM to render the universe into just above the script tag. Why is using Bootstrap? Oh, it's not actually. Why is this Bootstrap shit? A dependency graph that contains WASM must all be important. Asynchronous. This bootstrap file does the single async import so that no one else needs to worry about it again. This a dependency graph that contains any WASM must all be imported asynchronously. I don't get what this fucking thing is, but let's keep going. So now I need to do this before the bootstrap thing. I put this shit, right? ID game of life canvas. So this is where I'm gonna draw the shit. Cool. Additionally, we want the present in the middle of this web page. We can use CSS. I don't care about CSS, man. I know about this stuff. At the top of let's fix our import or bring the universe rather than the old greet function. Okay, cool. And I'm not gonna do this because I'm gonna use the greet function to print the pixel. Remembering my objective is to print a pixel. Print a pixel in the screen. Like my objective is not to build a game. Also, let's get pre-elements which is added an instance and new universe. Okay, cool. Can you just do this? But why? Wait, what is this? No, I see. He's importing the universe that was written in Rust. Then I think this is written in index.js. Yes, here. So here he get the pre tag. I'm not gonna write it by hands. Just copy. Cool. So he's getting the pre tag here. Now he can render the thing. Const render loop. The JavaScript runs in a request animation frame loop. On each iteration, it routes the current universe to the pre tag and then calls universe tick. Cool. So we have this render function. I see. So this is gonna run every time, but I still don't know how things are being drawn to the screen, right? Oh, is this text content? Anyway, let's do the thing here. So instead of this universe tick, I'm just gonna use my grid. I don't care about this. So this thing needs to return something that will be written in the pre-text context. Something like this. Let's just keep going so I can understand what is being drawn. To start the rendering process, all we have to do is to make the initial call for the first iteration of the rendering project. Make sure your development service is running, and this should look like. Rendering to canvas directly from memory. Rendering and allocating a string in Rust, and then having WASM by Gen converted to a valid JavaScript string makes unnecessary copies of the universe cells. It already knows the width and height of the universe. We can read webassembly linear memory that make up the cells directly. We modify the render method to return a pointer to the start of the cells array. Also, instead of rendering, my screen is lagging. It's lagging very much, I don't know why. Do I have something running here? Anyway, let's just keep going. Handling the camera directly from memory. Generating and allocating a string in host, and then having wasm binding gem converted to valid JavaScript string. But I already read this. I still don't know how he writes. What is CTX? Did he declare CTX somewhere there? No. Just show me the whole code, motherfucker. Draw cells. Draw bridge. It works. Cool. How can I see the whole code? I'm not understanding the code because I'm just reading like small parts of it, and partially webassembly memory, draw cells, cool. Fill style, so we can change the color, but I still don't know how this thing is being handled in JavaScript. Also, instead of handling Unicode tags, we'll switch to use the Canvas API. Web API, Canvas API. I think I need to go back and understand how is what he was using before this. Canvas API. Yes, this is the thing that I want to do. I don't want to use this spreadsheet. I want to write to the canvas. Cool. So let's go back to index.html. Let's change the spread to canvas, right? Cool. Yes. To get the necessary information from the REST implementation, we need to add some more getter functions for universe width, height, and pointer to cells array. All of these are exposed to JavaScript as well. Make these additions to as an game of life. Let's just follow the things that he's telling me to follow. Then I can think about changing it. So I'm gonna change this greet function. I'm just gonna follow the things that he's telling me here. So I have the universe. Man, savages. Tabs. Next, in wasm index, let's also import cell from wasm life and define some constants that we'll use when rendering to the canvas. So this is JavaScript. This is not. Oh, actually, he's doing everything. Because not everything, but most of the things he's doing it in JavaScript. Let's just follow the thing, then I can see if the code is working, and if the code is working, I can figure out how things are working as well. So, where is this cell thing? Cell. So, this is universe cell from wasm. Now, let's import cell from wasm. Let's close this thing here. It's too little space to keep programming like this. So let's do things here. I have some errors here because this universe and this cell doesn't exist, but I'm gonna put it here afterwards. So I have this thing here. I need to put. I see. I need to put this import here. Cell size, color. Cool. It's not pre anymore, it's canvas. And here is canvas, but I still don't know how to do the thing. So universe, construct the universe and gets width and height. Cool. This is the handle loop. So this should be the whole JavaScript part. I'm gonna replace it with the things that I have here. Cool. So I have universe new, width, canvas, documents, element by ID, yeah, draw grids. Where is this draw grids? Oh, this draw grids is from the universe. No, there's something wrong here. Like universe tick, I get it. Oh, you also need the imports. I shouldn't have moved the imports. Yes, now it's making sense. I have the cell, like the draw cells is still not making sense. Draw cells, you have the draw grid. So draw grid and draw cells is just JavaScript. To draw the grid between cells, we draw a set of equally spaced horizontal lines and a set of equally spaced vertical lines. These lines cross to form the grid. Cool. So just copy more code. So this is the draw grid. Now I need the draw cells. And point, we can directly access the linear memory via memory, which is defined the row as a module. To draw the cells, we get a pointer to the universe cells. Construct unit overlay the cells buffer, iterate over each cell, and draw a white or black rectangle, depending on whether the cell is dead or alive. Especially by working with pointers and overlays, we avoid copying the cells across boundaries on every tick. By working with pointers and overlays, we avoid copying the cells across boundaries on every tick. Really cool. Okay. So let's copy this. Oh, he's getting, wait, like, he's getting the reference directly from memory, right? Where is he's using memory. Oh, this is quite amazing. I shouldn't copy the whole thing because there is some things here that I don't need, I think. Yeah, this import memory should be here. Okay, draw grid, handle loop. The handle loop should go here. Oh, I'm learning cool stuff here. So get index, draw cells. This is only JavaScript. Yes, now almost everything is making sense. I think, like, of course, this code will not gonna work because I didn't write the Rust part, but I'm gonna write the Rust part and just finish the whole tutorial. To start the rendering process, we use the same code as above to start the first iteration of the rendering process. So note that we call draw and draw cells here before we call request animation frame. The reason we do this is so that the initial stage of the universe is drawn before we make modifications. If we instead simply call the request animation frame and the loop, we end up with a situation where the first frame that was drawn would actually be after the first call to universe tick, which is the second tick of the life of the cells. It works. Rebuild to webassembly and bind the glue tree by running this command from within the line. Now I have to go back and copy the the universe part, the Rust part. So the JavaScript part is done. I hope it's working. Now I have the savage part, the Rust part. Okay, I think I already copied this, right? This looks a lot bigger than the thing that I copied. Public method part to JavaScript. Let's see if I actually had to come back here in the beginning. Do I have any more code here? I just want to copy the code, man. I'm too lazy to read everything. And also my objective is not to understand how everything, like my objective is to just understand basically how Rust and JavaScript work together. I'm not actually interested in building the game itself. This is pretty much basic. I also need to understand this because this is basic Rust struct universe. Oh, I already have a universe here. That's why it's complaining. Universe in this scope, not found in this scope. Do I have anything before this? Well, I think it would be so much fucking easier if I just could see the whole app. Like, this is fucking ridiculous. Where's the link to the whole app? Project template, debugging, time profiling, setup, testing, debugging. I'm just gonna search here, like Razm Game of Life. Thank you. So I have the source here, I have the lead. No, this is different. No, it's not actually that different. This is something like, it's very old. No, it's not very old. Conversation about the repository contains the complete code of the Rust and webassembly server. Story-based implementation code. Lead the tutorial here. Is the tutorial that I'm following this one? Yes, it is. So this is the right code. So I'm gonna grab this code here and see if it works. Give me raw. I'm gonna remove. I'm gonna copy the code here. Why are you complaining? Universe in this scope. Why is this timer thing? He's not using the timer. The timer is. If it's not using, I'm gonna remove it. Fuck the timer. Why are you complaining? Can't find create websys. Why is websys? Oh, this is to console. Cool. So I can run the JavaScript console. I think it is this one. Let's find out. Websys crate. What is the site for the cargo crates? Cargo crates. Host cargo crates. Websys. WebSys binding for all web APIs, a procedurally generated crate for web. Cool. How can I install a crate? I think I already done this. Maybe it's cargo install. Cargo install. Cargo. Yep. How can I save to the thing, right? List, explain, build, check, clean, doc, new, init, run, test, bench, update, search, publish, install a host binary. Default location. So I just need to run install, what is the name? WebSys, and it's gonna install the WebSys. Specify package WebSys as no binaries. How the fuck do you install this then? Oh, fuck. Why haven't I done? Oh, is it? I'm gonna close this thing. So this is the whole package. Do I have WebSys here? Yes, I have dependency, WebSys. Do I have to put it by hand? There's no other way to install the shit. Install public search. Maybe I wrote the name wrong. Here is written as web-sys, but the name is web_sys. Dependencies. I'm gonna just copy this thing to cargo. Do I have two different dependencies? Dependencies dot WebSys. Dependencies. This is different, so I'm gonna put it in here. Now how can I do this? Cargo install no package found with binaries. I don't know how to install the thing. Oh, now he's not complaining anymore. Maybe he's gonna install it when I build. Yes, I think he's gonna install it when I build the thing. How can I build? I forgot how to build. I think it's cargo build. Let's see. Oh, he's downloading WebSys now. Yeah, cool. But there was an error. Use WebSys, not unused imports. This is a warning. This is an error. Use of unstable library feature host C private. This crate is being loaded from the sys root unstable location. Did you mean to load this crate from crates.io via cargo instead? CGF if. So this CFG if library is giving me trouble. I should understand what the fuck this is. CFG if. What the fuck is this? A macro to ergonomically define an item depends on a large number of CFG parameters. Structure like if-else chain. I still don't know what the fuck this is. A macro ergonomic. Just a fucking macro. Okay. The motherfucker uses this macro, so I need to install the macro too. What is the thing? Oh, I need to. Now I get it. I get why he's complaining. He's complaining because he's trying to get the package locally, but it should be installed as a dependency. Cool. I still think it's kind of weird to have to manually change this file, but I think this is the way that Rust people do. Now just it's finished. It's just warning me that the console is not being used, right? Let's just check if the console is being used or not. We have console, yeah, you have console here, is not being used, so he's warning me. So I should like change this thing. Let's help the dude. Let's help this dude that wrote this thing. Yeah, let's make a pull request changing that thing that is not being used, right? Unless he's using it in the timer that I removed. Let's just find if he's using or not the console. Yeah, he's actually using the console in the timer. So his code is right. My code is wrong because I'm not using the timer. He's not calling the timer, so it's kind of useless. All this code is useless. But maybe it's something that the tutorial went through. Like the tutorial went through creating the timer and things like this. So that's why it's commented here. So it's fine. Let's keep going. So now I built the thing again. Let's try to create it. Let's try to run it again. npm start. Oh, it fails. 1. Export cell was not found in WASM Game of Life. Warning. Export universe was not found in WASM Game of Life. So he's complaining that I'm gonna remove the shit, right? Fuck it. I'm gonna make it. So export. How do I export things here? In Rust. Like I have a cell. Toggle, universe, get index, get cells, live neighbor count. Oh, you have this choose search panic. I don't think this when the console panic feature is enabled. The search panic function I don't think this is important. But I have this guy here. Personal site pg resin personal I don't think I have anything else besides the things here, right? I have a cell here. What is this imp L? What is this? Universe. Now here I understand that I'm creating a struct. I'm defining it. Let's just understand what the fuck this is. First, imp. The imp keyword is a primary to define implementation of types. Oh, cool. Now here's I'm defining a type cell. Here's I'm defining the implementation. Like imp is for implementation of this type cell. Cool. Get it. Now here's I'm creating the structure universe. Here's I'm implementing the type universe. Cool. This is the function inside this structure. It's a lot like C. Public method is important to JavaScript. Oh. Why do I need this WASM by gem everywhere? It's kind of weird. WASM by gem public method exports. There's some things here that I'm not understanding. Like I understand it until here. Like I understand that now we declared the universe struct. Then we are implementing this struct. Then this part you don't understand. Public method exported to JavaScript. Oh, I think I get it. This is the private part. Yes, this is the private part, and this is the public part. So I'm exposing the check function to JavaScript, but how do I expose it? I'm not understanding this, right? Because I have the Ryzen by gem here. How do they know that this is public? How the thing knows that this is public? With cells display for universe. What is this right? Right. Cool. Let's keep going. My start's not working because of the export universe was not found in the WASM game of life. How was it not found? Let's see how it is important. He's importing this thing, like he's importing universe, and he's importing cell, and he's importing memory for WASM Game of Life BG. WASM Game of Life background. Cool. I think I already can draw, like I already can finish my objective, but I also want to understand this. So I'm not going to stop trying to understand this. So let's first understand how he can expose the implementations here, like the universe and the cell. So let's go here. Let's like make it real easy to understand how to expose things. How can I do this? I can create a copy of this file. I'm gonna like do copy, and I'm gonna remove most of the things. Right? I think it's the right thing to do. Like, let's go to the beginning, the hello world. There's a lot of shit that I don't think it's needed. Like, why do I need these utils? What this thing is doing? Module provides common tools to make working with compile. Webassembly, take a look at some of the utilities from. This is for debugging. But the only thing that I need to export the thing is just declare it, right? I declare a function here, a pub function. Maybe this guy should be pub. Right? This one should be pub. I don't know. Let's keep following this one. So, WASM reach. Put it into our web page. Saving locally. Okay. Rules. This is the rules of Game of Life, so I don't think it's important for me. Where is the code for this thing? Right? Why is there isn't this big? Man, this tutorial is just missing a big part of code, like implementing live. I think I should read this. Interfacing Rust in JavaScript. Yeah, I should definitely read this. I'm gonna make me some tea and I'm gonna read it. This is one of the most important concepts to understand and take away from this tutorial. Yes, it's definitely the most important concept. JavaScript garbage collector heap, where I then don't know it's allocated is distinct from our assembly linear memory space, where ours currently has no direct access to the garbage collector heap. This is expected to change with the interface types proposal. JavaScript, on the other hand, can read and write to the WebAssembly linear memory space, but only as an array buffer of scalar values. Assembly function also trigger return scalar values. These are the building blocks from which all the assembly JavaScript communication is constituted. webassembly defines a common understanding of how to work with compound structures across this boundary. It involves am I still recording? Man, my cam is really delayed. But it does not remove the need to consider a data representation, but when designing interface between WebAssembly and JavaScript, we want to optimize the following properties: minimizing copying to and out of the assembly linear memory, unnecessary copies impose unnecessary overhead, minimizing serializing, deserializing. Similar to copies, serializing and deserializing also impose overhead, and often imposes copying as well. If you can pass opaque handles to a data structure instead of serializing it on one side, copying to some known location to WebAssembly linear memory, and then serializing on the other side, we can often reduce a lot of overhead. webassembly jam helps us define and work with opaque handles to JavaScript objects or boxed host structures. As a general rule of thumb, a good JavaScript WebAssembly design is often one where large non-lived data structures are implemented as host types that live in the WebAssembly linear memory and are exposed to JavaScript as opaque handles. JavaScript calls a spotted WebAssembly function that check these opaque handles, transform their data, perform heavy computations, query the data, and ultimately return a small copyable result. Cool. By only returning the small result of the computation, we avoid copying and or serializing everything back and forth between JavaScript garbage collected heap and the WebAssembly linear memory. Interfacing host and JavaScript in our game of life. Let's start by enumerating some hazards to avoid. We don't want to copy the whole universe into and out of the WebAssembly linear memory on every tick. We do not want to allocate objects for every cell in the universe, nor do we want to impose a cross-boundary call to read and write each cell. Where does this leave us? We can represent the universe as a flat array that lives in the WebAssembly linear memory and has a byte for each cell. A 0 is dead cell and 1 is a live cell. Here's what a 4x4 universe looks like in memory. Cool. To find the array index of the cell at a given row and column in the universe, we can use this formula. Index, row, column, universe. All time we have several ways of exposing the universe cells to JavaScript. To begin, we will implement std_fmt display for universe, which we can use to generate a host string of the cells rendered as text characters. This host string is then copied from WebAssembly linear memory into JavaScript string in the JavaScript garbage collected heap, and is then displayed by setting HTML text content. Later in the chapter, we evolve this implementation to avoid copying the universe cells between heaps and to render to canvas. Another viable design alternative would be for us to return a list of every implementation. In the last chapter, we cloned the initial project template. We will modify the project template now. Let's begin by remove the alert, import, and reach function and placing them with the type definition for cells. So I need to remove the reach. Wait. Let's go back to the hello world example so I can follow everything now. Fuck. Get out of here. So this is the hello world thing. Does the hello world thing works? This is my question. I should make I'm gonna make a script to rebuild every time I change anything here, so I can better understand and I don't have to every time be running this thing. Yeah, this is not gonna change, right? Or yeah, I think this is not gonna change, because if I'm running this here, I can just change the JavaScript code and it will work. Let's just test this thing first. So if I build again here, functions never used, cool. And if I run this thing again, now it should work. Oh, what? Can't resolve. Oh, I need to change this part too. Yes. I want to change this, but I don't want to lose everything. So I'm gonna create a copy. Create a copy base. I'm gonna put index copy. And now I'm gonna change this back to where it was before I start copying the whole shebang. So this is it's just this, I think. Pointing to web page. I already have this, and I didn't change anything yet. I just put the canvas thing. And yes, the dependencies are already installed. So I need to change everything here to this. Now let's run it again. I think now it works. Yeah, now it's working again. And now I can follow the tutorial like a decent human being. So this part is already good. Implementing in my flag. I think I was reading this part. Cool. I'm gonna make me some tea. Then I'm gonna write the bash script to rebuild everything, so I don't have to rebuild everything by hand every time, which is pretty tedious. And then I'm gonna keep following the tutorial, and that's it. I can listen to my beating. Yeah, I'm gonna cut right now. Yeah, this is the lane, so fucking stupid.